wanted to make a very short presentation of what it's about, why we are doing this, and who we are, right? So probably most of you already know who we are. So in principle, this is a joint event organized by UBICS, the University of Barcelona Institute of Complex Systems, and complexitat.cat. Actually, they have two different goals. So in principle, who we are, in principle, these two different names are not, so they have some overlap. Actually, it's try to put together all the people that are working on complex systems in Catalonia, and also in a very broad sense. So the idea is to make it even broader and then to incorporate people from different disciplines. In principle, the goals of the two are different. So complexitat.cat is a kind of a public association where the people belong as individual researchers basically at Catalan level, even if we have some, let's say, some abroad memberships very well received, as Manlio, for instance. And then UBICS is on the other hand, is located physically and institutionally at the University of Barcelona. Actually, the idea, it's the ambition of most of the people that are forming part of these two institutions. The idea is at some point being able to create a kind of a Catalan space for complex science. Okay, so why are we here? Okay, because of this virus, because this has been probably the biggest disruption in our lives. Probably not personally, but as a society, as a collective people. So, and then it has been, we have had to change so many things. But one of the points is that even it has changed, very strong change in science. So we don't know now what will happen with economic resources allocated to different goals nowadays. So, for instance, we know that here in Spain, of course, are moving, let's say, resources from one place to another place, and of course, this makes a very, let's say, great disturbance in even for, let's say, scientific groups. And okay, that's the reason. So because then we thought that being these complex system scientists, then we realize, so which is the research that is being done and which is giving publicly some information, and then you realize that it's some people that belongs to our community, so people that define themselves as complex system scientists. And not only this, some of these people, we have it in our community, and we have had them very, very close to us in the past, or we even expect to have them also in the future. And then realizing that this research towards the COVID and all these implications, why and what can happen in the future, it can have some, let's say, some response from different disciplines. And all these different disciplines, the idea is that they're able to merge in some sense and finally offer some kind of complex collaborative response to all these problems. And that was the reason for which we started. So because we think that these four seminars that you have here, this is just the starting. The idea is, okay, if we get some support and then we can continue doing this. The idea is to continue in the future, incorporating people from many different disciplines. So you see here, this is the schedule. Probably all of you already know, and I'm going to go fast over this. The idea that Manlio that will talk about the first talk. And then we acknowledge him for trying to do this type of a big introduction to complex systems for scientists. Then we are pleasure to have Nuria Oliver in the second day. Nuria Oliver is an engineer, computer engineer, communication engineer that is working a lot in official institutions in Spain fighting the COVID. Then we have in the third day we have Santiago Elena, who is a very well-known, recognized virus researcher. So he will bring us the views more from the biological side. And then finally, we have a kind of mixture of everything that Alex will talk about: epidemic modeling, and also how this epidemic modeling is related to mobility and which are the effects that in economics it has, the successive lockdowns that we have been suffering in our, let's say, Western societies, and which have been the effects of this. But mobility, we realize that how people move, mobility plays a crucial role in all this developing of this virus. So that's it. So you have here been pictures of smiling, all of them, Manlio, Nuria, Santiago, Alex, a little bit more serious. But that's it. So those are the people that we'll have in the next session. And then I just hope that you enjoy this set of lectures, and then you are attending today, and we hope that you will be back in the next days. So now it's a pleasure to give the word to Luce. Luce will make a short introduction to Manlio.
Hello everybody. It's a pleasure to be here today, and a real pleasure for me to introduce the speaker of this first UBICS webinar today, Manlio de Domenico. He is the head of the Complex Multilayer Networks Research Unit as Comune Lab, currently within the Department of Digital Society of Fondazione Bruno Kessler in Trento, Italy. Okay, let me say that Manlio got his PhD just 9 years ago under the supervision of Professor Vito Latorre, and is already one of the most renowned researchers in the field of complex systems. After his first postdoc at the University of Birmingham, he joined Alex Arena's teams in Tarragona, so he's already part of this Catalan community and complex system. And he left in 2017 when the Fondazione Bruno Kessler gave him the opportunity to establishing its own research group. Manlio has contributed to the foundation of multiplex and multi-layered network, probably the most productive research line of the last decade in complex network, achieving very important results both in the theoretical foundation and in the realm of applied research, with application in field as diverse as the system biology, system medicine, as well as computational social science, computational epidemiology, and data-driven policy making. Recently, we can say that he has been working a lot on social technical systems that are systems where social interaction are somehow mediated by technological device. And the most well-known examples of these are online social platforms. And he has been focusing on the collective phenomena that take place on them, and that part of our daily life as citizens and users. Like, for instance, in the case of the infamous issues that we are nowadays with the disinformation campaigns. And in this framework, Manlio's Comune Lab is currently collaborating with the World Health Organization, developing an infodemic observatory to help policymakers managing the overabundance of information related with the COVID and coronavirus. Something that makes it hard for people to find what are the trustworthy sources. The observatory is already online. You can find it if you can follow Manlio on Twitter. He has a fixed tweet, but it's very easy to find out this website where you can find a lot of insightful data and visualization about the coronavirus infodemics. And it is also supposed to be operating for governments worldwide by the end of this year. And I think that's all. Let's not waste more time, and let him give this very interesting talk that he's gonna give us today. Thank you.
So thank you very much, Luce, for the very nice introductions. First of all, I would like to thank the organizers of this very interesting initiative, because I think it's very important for the community of complex system scientists to have this type of initiatives that are open to a lot of people, even the people that who cannot travel very easily. So we have some issues, as we have been discussing with Albert about the lack of the possibility for having a coffee together or a beer after the talk, but at least we are able to reach a lot of more people to let them know about the relevance of the complexity science and the role that complex systems science can play during a shock like the one given by the COVID-19. So today I have been asked to give also an introduction to complexity. Now probably you will see in a while why. So let me start with one tweet, since we will talk a lot about tweets. This tweet comes from a guy on the 20th of July in 2011. And as you can see, it's a tweet in Spanish, but actually the guy was located in New York. And he said that he likes to do the history instead of read over it. And this tweet was just retweeted and reached very few people in a couple of days, until it reached the right people having managing accounts of Twitter accounts in New York, who were considered like local spreaders. And from July to September, this happened. So the Occupy Wall Street movement took place with all the consequences that we know. The interesting thing is that this is not the only case that we see in history. 1 year before, more or less, and so in December 2010, there was a guy who, to protest, self-suicided publicly in the city of Sidi Bouzid in Tunisia. And that event actually led in less than a couple of months to the Arab Spring. So first was the Jasmine Revolution, and then the Arab Spring covering the whole northern part of Africa. And as you can see here, in March 2011, so just 3 months later, Twitter and other social media were used to coordinate across the people, across the countries as well, and to schedule the protests and to provide the world with a way to follow what's going on in that area of the world, thanks to videos, pictures, and the possibility to record everything. And this actually is the very important thing and the start of the revolution provided by social media, and especially the social media like Twitter. The Occupy movement was considered a decentralized and leaderless movement, and you will understand why it's in bold text here in a while. Able to mobilize thousands of people. And the Arab Spring was, after the analysis of tweets, the analysis revealed that normal people were driving the movement, and social media were considered the way to create a new space for how history will be remembered and will remember its events, and a way to empower population to record what's going on. But we have other examples not related to protest, or at least not to revolutions, or let's say another type of revolutions. I like to talk about this. In 20 August of 2018, this little girl, she was 15 years old, sent a picture of herself with just a piece of text talking about her protest for climate in Sweden. And as you see, the tweet was in Swedish. After 2 years, exactly, the same girl was leading a movement with millions of people worldwide about the climate protest. Something that is remembered as the September climate strike. And as you can see, she was able to move in less than 2 years from herself alone in Sweden to mobilitate 170 countries and thousands of events around the world. And then we go to the latest ones. So just as you probably know, 3 weeks ago, more or less, something happened in Minneapolis. And this was the first tweet about it. It was about the attack of the brutality of police towards a black guy exactly in Minneapolis. This tweet was the one used to trigger the attention of the US population towards the Black Lives, and trigger again the attention of the movement named the Black Lives Matter, which is not the movement born 2 weeks ago, but is older than that. Actually, a couple of years older than that, and that I have been following it on Twitter since the very beginning. The interesting thing is that, once again, Twitter was used to record history and to share the history with the rest of the world. So it was a way to move, so to share the information and to allow the information to reach anyone. And it's very interesting, the dynamics around this specific case. I don't know if you know who are the K-pop stans. So they are the fans of the Korean pop stars. And in order to fight the countermeasure of the police, they started to flood, to mobilitate with each other through Twitter and to coordinate massive attacks to the police departments and to share with them a lot of useless content like dancing and stuff like that, exactly the type of content shared by K-pop stans. In this way, they started to really fight against the fascist-like countermeasures provided by the police in the country. And as you can see, thanks also to this type of social dynamics, in less than 1 week, the mobilization was getting 50 states, so all the states in United States, and involving a lot of other people from other countries, but also other communities, celebrities, and so on, reaching a very, very large public. But of course, there are also dark sides of the power of the social networks. Here we have another example, which is Hong Kong. In Hong Kong, you know, there were protests against against China for political reasons, and according to news reported by CNBC, China started to develop information operation in Hong Kong that was based on the disclosure of 1,000 accounts, more or less, spreading disinformation and misinformation in order to generate political discord in Hong Kong. And then, of course, you probably are familiar with the scandal about Cambridge Analytica involving Facebook and the leak of personal data of millions and millions of users in US with the aim of performing micro-targeting during presidential elections in 2016. And then, of course, it depends on the person, on the user of accounts like the one of Donald Trump, who's now 80 million followers, where you have a lot of power with the social media. Here, the president of the United States called for the liberation of Virginia because it is under siege, and this led to a movement following the word of Donald Trump. So with evident issues for public order, for instance. And then, of course, there is also this other community, this account that is the community of Anonymous, is a community of hackers who are activists and are involved in many issues related to public order in several countries, or regardless of the country. And here as well, they are the government is performing information operation in order to fight Anonymous. Just to remember, Anonymous is that group able to share secret information and leaked information from even from politicians and so on. So they are very, very powerful because they share information. So the government is really fighting them with all possible ways. So you understand that our society is what we call a complex system. And I always like to show this slide. It was a quote from Stephen Hawking in January of the 2000, so at the beginning of this century. And he was mentioning that this century was going to be the century of complexity. Instead, the previous century, at least for physics, it was the century of quantum mechanics and general relativity, so the revolutions of in physics. But what is a complex system? So a complex system is a metaphor for real world systems, which consist of interconnected units. So units can be people, can be neurons, can be cities, can be animals, but can be junctions in a city, can be proteins. And all of them are related by the fact that they interact with each other in some non-trivial way. And this is true at several scales. So it's true from the scale of the sub-cubic meter, so at the level of the human brain, where you have billions and billions of neurons and almost 1,000 more times more connections between them. But it's true also at the level of the whole cosmic web. So for very, very large scale, you can see the patterns. And the interesting thing is that those patterns are recurrent across scale. Here you see a city, and you have cities, and below you have, which is a spatial complex system, and below you see a neural system, which is another spatial complex system. And you see that the generation of the patterns is pretty similar. So the question is if those patterns are universal or not. And I always like to mention the fact that biology is emblematic. So it's a very important discipline where the relevance of complexity is really manifest, because you have DNA, which is where you have the best ingredients, of life, and then they connect with each other, they interact with each other, and then you have the transcriptome with the RNA, and then those proteins interact together in order to build the proteome, and so on, passing through pathways and neural circuits and organs and tissues, and arriving to organisms, and organisms organize themselves in populations. So you see that from this perspective, you have that everything is really connected across scales. And complex systems are characterized by the fact that they produce collective behavior, something that involve all the units in the system, because information flows very fast in such systems, and in fact very often they are called adaptive systems. And the major goal of complexity science, I think, is to try to understand the specific set of mechanisms which are able to reproduce a lot of the phenomenology that we observe right now, but it also we have been collecting in the last decades. And here you see some simulations of some models which are very famous in the field, and are able to reproduce some of those features. And here you see just the complex systems that I have been working with in almost the last decade, ranging from molecular systems to urban systems, as introduced by Luce at the very beginning. So in August 2018, I decided to ask the community, just for fun at the very beginning, the community of complexity scientists on Twitter, if they were able to explain what's complexity about in the size, using the size space of just one tweet that at the time was still 140 characters. The response was fantastic, because many people, also including the organizers of this session, but also the other speakers that you will see in the next sessions, and other very relevant complexity scientists. So they interacted. They were happy to contribute to this call, and to provide their own view about what's going on with complexity science and how you can try to define complexity science. And I really loved, besides the technical descriptions, I really loved the poem shared by Peter Dodds. He shared this in order to explain the concept of emergence. We are going there in a while. But the point is that he was able to put all the feeling that we have about emergence in just 3 lines. That is, there is no love in a carbon atom, no hurricane in a water molecule, and no financial collapse in a dollar bill. Really capturing the essence of emergence. But complexity is an old matter. So we have decades of science from very different disciplines that are not yet really coordinated with each other in order to talk about it. But here you have the example of cellular automata, where you just produce a very few rules, mechanical rules, if you want, which are very simple. Like if you have 3 blank cells, then in the next step, one of them will become filled. Okay, so a black square, and so on. You can define very different rules, and so on. The nice thing is that when you do that, you end up with a system which is very rich in its dynamics and is able to show some properties that were unexpected at the very beginning. So those properties are not encoded, were not encoded by the people, by the equations, but are properties, features that emerge, that spontaneously appear from the way the system naturally evolves. And this was pretty interesting, because it put, with this example, this is the Conway's game of light, it puts the first bridge between the theoretical approach to the problem and the computational approach to the problem. And with that, of course, more recently, you can really simulate a lot of complex systems that you find in nature, like, for instance, the evolution of an amoeba, or the spread of a fire in a real forest, and so on. So it's a very rich framework. But the interesting thing is that this is not by chance. So in practice, what it has been discovered more recently. The Conway's game of life actually is a universal Turing machine. So a Turing machine is the paradigm of our laptops and our devices like your phone. And then a universal Turing machine is just a Turing machine that is able to simulate an arbitrary Turing machine based on arbitrary input. And the Conway game of life, with its 3 simple rules, is actually a universal Turing machine. And there is a strong connection between this and the fact that you have the emergence of complexity, at least from a computational perspective. So what does it mean to be complex? In 2013, there was a nice definition, both at the theoretical and operational level, by Lediman, Lambert, and Meissner, that a complex system is an ensemble of many elements interacting in a disordered way and resulting in a robust organization and memory. And operationally, a complex system is a complex if it can generate data series with high statistical complexity. So we have been trying to better understand what are the ingredients of complexity, because not all systems are, of course, complex. And one ingredient, of course, is nonlinearity. So the fact that a linear combination of the input does not really correspond to a linear combination of the output that you get. And an example is the double pendulum. So the pendulum attached to another pendulum. As you can see, there is a very rich dynamics over here. And those pendula there started from almost the same initial conditions, but they evolved pretty different after a while. This property is called the sensitive dependence on initial conditions, and is a landmark of chaotic dynamics in low dimension. And a very emblematic example is the Lorentz attractor. So the fact that it has been discovered in the 60s, and during the attempt to model weather, and it led to the famous sentence that about the importance of the flap of a butterfly wing in Brazil for the appearance of tornado in Texas. But we have other properties. For instance, feedback. Feedback is the fact that a system is not isolated, but it continuously take inputs from the environment, and that input interact with the system, alters the system. You think about an ecological system where you have predators and prey. If you have many predators, the number of prey will decrease. But if you have not enough prey, then also the predators will start to die or will have to move. So you have a kind of periodic oscillations due to the feedback effect. And then we have, for instance, the emergence or the appearance of spontaneous order due to the mechanism of self-organization. And why that's important? Because it can be used for practical applications. Now, self-organized nano machines are thought to be used, for instance, in medicine, in precision medicine. And of course, robustness and the fact that and other properties related to robustness. Here, I should dedicate a talk just to this, but just to let you know that depending on the internal structure of the system, you have a different response to external attacks or to internal failure of the system itself. And then the lack of a central control. If you remember my previous slides about the Occupy Wall Street movement, it was a leaderless and decentralized movement, exactly one of the landmarks of complexity. And then we have emergence. Emergence is something that is still not really characterized. It's something magic to me, because we are able to measure it somehow, at least to measure its effects, but we don't really have a definition for emergence beyond the fact that there is something that spontaneously appear at some point. And for instance, intelligence is an emergent property of a neural system of our brain, like life is an emergent property of the interactions, of molecular interactions at the level of a single cell. And hierarchical organization, of course, is another landmark of complexity, where it reminds me about self-similarity of systems. So you go across the scales, you see that complex systems actually are similar to themselves across those scales. And also the type of interactions that characterize their structure is similar across scales. And eventually, I think that one of the major features is numerosity or diversity. So you need really a lot of elements, of units to have a real complex system. And I like this because we see the effects of feedback and nonlinearity and coordination and synchronization and all the stuff that I have been discussing so far. For instance, even during a concert, where you have people moving in response to the music. So these are some, or I would say, the main features of complexity. But more recently, something more happened. So if you want to have a clear idea of complexity, you will not find them like on books like a well-defined theory. Actually, it's a collection of theories based on phenomenology across disciplines. So this is the literature about complexity published publicly available on the archive in the last 20 years. And I have done this map from the words used in the abstracts of the papers. And you see that you have applied math, you have social science, and neuroscience and computer science, you have physics, you have biology, evolutionary biology, you have sustainability, so even fields of engineering and so on. And network science, for instance, he's here and displaying the role of a kind of separate field, bridging different other fields. So this is pretty interesting. And just to conclude about this part, all of the things that I have been discussed so far have been also the result of the call that I made on Twitter 2 years ago, have been merged with the efforts of many other people around the world, so being part of the community of complexity science, in order to create this booklet with my colleague Hiroki Sayama, his professor in US. We have coordinated those activities, but this is really an effort by the community. And here you see the contributors and also the people involved in the call over Twitter. So you will find here the link, and you will be able to play interactively with the definitions characterizing complexity. And also you will find complexity explorable, so many apps where you can play with that have been developed by Dirk Brockman for this purpose. And you have to acknowledge the fact that the community started even to translate in several languages. This is not really representative. There are a couple more here of more languages. And you will find the one in Catalan, of course, but probably you will find the one in your language, because we cover, to the last time that I made the numbers, the languages spoken by more than 4 billion people. And you will find, of course, definitions or attempt to define what complexity science is somehow. But as I was telling you before, something happened almost a decade ago, actually a decade ago. And the fact that we recognized, actually someone before me, because I was not working in the field 10 years ago, recognized that nature consists of system of systems. And you see, for instance, in the human body, where you have different systems like the circulatory or the respiratory, the skeletal system, the neural system, and they are interdependent with each other. They're interconnected with each other. They cannot live in isolation from each other. But you have also other cases like the supply chain or the system regulating transportation and telecommunication and electric power, energy, and so on. So they are all systems of systems. And you actually are familiar with the effects of the existence of those interdependencies. The eruption of the volcano in Iceland in 2010 caused worldwide traffic delay, affecting the movement and the mobility of people in Australia on the other side of the world. And similarly, the fact that there exist those interdependencies, you have the human activity is actually actively having effects on global warming and climate change, but this is affecting species and population of animals worldwide in specific parts, so with species extinction or at risk of extinction and new migrations. And both of these effects together will lead to a food web disaster. And again, altogether, this, closing the feedback loop, will affect again the human activity. So you see that the landmark of complexity is here. And concerning the COVID-19, you have something pretty similar. A small virus in China was able to generate in a couple of months a pandemic affecting millions of people worldwide, with thousands and thousands of deaths and fatalities, and causing lockdowns. And lockdowns are affecting actually economy now. So with the crash of stock markets, and we are going to see it very well in the academic system, the effect of this the stock market crash, but also caused the emergence of a new phenomenon. Actually, a phenomenon was already known, but in this period it was huge. It is the infodemic, and we are going to talk about infodemic in a few slides. And infodemic actually is having a huge effect on public safety. So someone a few years ago already recognized, or policymakers already recognized the importance of the interdependencies and the fragility of our society. Here there is the map that I did for the World Economic Forum for the World Economic Forum data about global risk and trends and how they are interconnected. And you see that there is the spread of infectious disease over here that is connected to environmental catastrophes, but also to illicit trade and financial mechanisms and so on. So everything is really connected and cannot be understood or even tackled in isolation. So here we have a new ingredient of complexity, that is multidimensionality. What I have said so far. So the existence of interdependencies among systems, or system of systems. So let's move quickly to the application to socio-technical systems. Here, why they are relevant? They are relevant because, as I told at the very beginning, they are able to affect our lives and how we interact with each other. And we observed in the last 10 years a lot of unexpected effects affecting human behavior, collective attention, depending on how information is diffused, but also attempts of social manipulation and the rise of echo chambers due to social media. I worked on this matter, proposing models of social systems based on multi-layer modeling. Just to be very, very brief, here you can have in the physical world, the same people can interact in different ways depending if they are connected by family ties or friendship ties, for instance. And here you have the spreading of disease or behavior. But then you can interact also in the virtual world, where you can have even other type of actors if you want. And one layer here is Twitter interaction, and another layer can be Facebook interaction. And here you have the spread of information, and all of them interact together. Here there are just a summary of the results obtained very, very recently for our study, a study done by my lab in the last couple of years, with tons of very interesting results. But the one that I really like to mention is this one, is the study that we did 2 years ago about the events and the social dynamics during the Catalan referendum of the 1st of October 2017, where we have discovered for the first time that social bots were not playing randomly in the network, but were really targeting people well placed in the network according to specific metrics that we have identified. So the circulation of information was not random at all, and we have been discovering that independentists and unionists were targeted in a different way. So in order to sustain the conflict, the online conflict, so if you want to sustain the anarchy on Twitter about this matter. And then moving quickly to the COVID-19. So you know probably better than me what's going on around the world. This is just a slide to summarize the effects of COVID-19 on death, so fatalities around the world. Here in this plot you have death from the 10th of March for different countries. And this is another picture that is very representative of how a complex system reacts to external perturbations, to shocks. Here we have our complex system is the society and its function over here, and here you have the time course. And you see that the COVID-19 pandemic was a shock acting here, and the response of the system was, of course, to fail on different points. Here you have, for instance, public health, of course, but also finance and politics. But as we are seeing also in the United States, the society. And then there will be, of course, a phase of recovery where the system will recover thanks to our action, so what we are going to do on the system. But you see that even if we start from the same point, depending on what you do and how you act and when you act, you can have different outcomes. And outcomes can be suboptimal with respect to the very beginning, can be optimal, so you reach the same state you had at the beginning, super optimal. And this is actually something that we already observe out there with the real data. So my PhD students, Sebastian and Barbara, are studying exactly this type of response from real data. And here we have human mobility from Google data in Italy at subnational level. And you see here that the shape of the curve is exactly or quite similar to the one that I have shown before, and the same applies for Spain. And let me say that the same applies for all the countries that we have been analyzing so far. So it's not limited to human mobility, but it also affected stock markets. And here you see data from real data for the behavior of the stock market in Italy and in the US. And you see that again, the response curve, well, of course, it's evolving differently, but the shape is always the same. So let's move to something that is pretty interesting. So a kind of emergent phenomenon happened during this specific shock of the COVID-19. That is something that we have been warned about by the World Health Organization in the early February. And then it has been taken seriously more recently by United Nations and also the academics, so also journals and so on. And the fact that the pandemic is really accompanied by an infodemic, that is an overabundance of information where the accuracy can be high or not. But the fact is, it's hard for the people to understand what to trust and to in order to learn about what's going on worldwide. And for instance, this is another in-depth study published by the New York Times just 1 month ago, where they show how an information about coronavirus research is being weaponized by governments and other groups. And here you can read the story. It was just to mention, again, to stress the power of social media. So we have the virus on the one hand, that it travels on transportation networks, and you need epidemics, so with generating in epidemics. And on the other hand, we have information which is traveling faster than the virus because it uses links through social media in order to diffuse. And here you need the field of infodemics. And the two things cannot be disentangled. So you cannot understand the one on the other without considering them together. So no isolation, they are entangled processes. And the way you have the spread of viruses or information actually is pretty similar to some extent, okay? And you have, you start from the micro scale where you have the laws of complex contagion, and you can use those laws in order to understand the mesoscale dynamics of the system, and then you can move up to the macro scale. But this is a paradigm for the spreading of for spreading phenomena in general, from information to behavior, emotions, pathogen, and etc. So, and what is an infodemic? In an infodemic, you have a system. So here you have the people online, but it's all not limited to online. And you have people sharing information. Information can be reliable, so green, or unreliable, red. And you have a lot of these seeds of information in the system. The point is that the information is spread, and you can have the spread, so you can reach people in different way in different part of the network with reliable information, but there will be an overlapping with unreliable information. So the point of infodemic is that at some point you have a mixture of the two, reaching the same people with even in different type of so with information about the same thing but contrasting with each other, so from different sources. And to better understand infodemics, you have to measure it. So with our lab, we started to collect data from mid-January, and to date we have collected more than 500 million tweets, analyzing more than 87 million news sources, so the websites with news in the system. And for all of this data, we have performed a different type of analysis. So here it enters the relevance of big data for understanding complex systems like our society. And we have been performing detection of bots, humans, psycholinguistic analysis, fact-checking, and analysis of how the information cascade developed through the system. And as you can see here, we cover different types of news categorized in different types, from conspiracy theories and junk science to fake news or politically biased news, clickbaits. But here we have also mainstream media and science or other types of information. And we have discovered that 70% of the information over here is reliable, but 30% is not reliable or biased. And 42% of the information it comes from non-human or software-assisted accounts. So we try to develop metrics in order to measure these things, and we ended up with we've been inspired by epidemiology, and we ended up with the attack ratio, a measure equivalent to the attack ratio developed in epidemics, and we call it the infodemic risk index. And thanks to this measure, we have been able to have a map now of what's going on around the world. And you can see here that we are able to do this at country level, continent level, but also at sub-regional and sub-national level. And what is interesting here is that you have the infodemic wave that is actually hitting a country before the epidemic wave. Okay, so this is expected because information travels faster than the virus. But when the epidemic hits the country, the infodemic wave disappear, or at least is very, very reduced. So we asked ourselves if it was a common factor across countries, and the short answer is yes, it is. And if you have questions, I'm not don't go through the details, but this is not an effect of any of these biases. So we have been able to disentangle a lot of potential biases in order to assess if our result was due to them or not, and the result is over there. So it's not a matter of having specific type of biases due to the platform or the way people is using the platform or geocoding issues and so on. The overall result is that across the world, when you take into account all the countries, you see that here the infodemic wave accounted by our measure and the cumulative number of reported cases. So the epidemic wave, there is this relation that is an inverse relation. And if you do a statistical analysis at a deeper level, you see that the difference between this part of the epidemic and the last part is really relevant, is statistically significant. So just to conclude, this work has been taken into account by the policymakers. This is actually what we aimed to. And we are actually collaborating actively with the World Health Organization in order to move our infodemic observatory to a higher level, in order to provide governments and policymakers with a tool to assess the infodemic risks in their country. And huge collaborations like the CLARE, this is a confederation of laboratories for artificial intelligence research in Europe, asked me to coordinate a specific task about social dynamics in order to understand how they can help in order to reach a full maturity for this field, thanks to artificial intelligence. And World Health Organization just 1 month ago reported that infodemic and misinformation is a problem is a threat to the public health, and they invited the governments to take actions against it. So thank you very much for your attention.
Thank you very much, Manlio. And now if
I would like to say that we have a very big clap for this, but thank you very much for your very nice talk.
Already three questions.
Okay.
So let's start with the first one from Alvaro. It's a great talk. It's not clear to me how one decides if something is fake or not. It's a very philosophical question.
It's a very philosophical question.
Okay, I think that since the second one is not a real question and the third one is quite larger, we can start with this first one and then proceed to the other one.
So the question by Alvaro is quite good. Actually, the way so if the question is related to how one in general can recognize if something is fake or not, there are a few guidelines. For instance, the WHO published on their websites those guidelines, but usually you recognize that news is fake if there are a few specific, at least a few specific features, like the fact of being sensational. So starting talking about something that is able to capture your attention, but then you have to see what is the source. Actually, our way to distinguish fake news from mainstream media and so on was based on the sources of those news. So we have an internal database of thousands of sources, media sources around the world, covering actually 127 countries in the world, and we linked the URLs of the tweets that we have in the tweets to the sources. In this way, the sources are the news are labeled as fake or not, depending on the fact that sharing was by was pointing to New York Times, for instance, or to a less reliable website.
Let me add just a bit something in the same line. When you are trying to do this, all this kind of operativization of these concepts that in real life are quite complicated, you are somehow, can you say that we need to binarize something that in reality is more shaded, or something that is a continuous variable between something that is corresponding to something true, some kind of real news, when half truth, and then you have the fake news. But it's not it's when you have to do this kind of study, you really have to distinguish between different cases. So
it's a good point, and that's why we don't use a binary classification. So we have a broader classification with up to 8 classes. Okay, and what you say is really true for politically biased information. So where they use a half truth in order to, as a ground to build on that. But it's also a landmark of conspiracy theories. The best conspiracy theories are the ones which are based on something that at the very beginning also is true, but then they put details which are not true. So the fact that the coronavirus is a virus, is a disease that is close to the flu. Well, this is not false, let's say, but it's not a flu. But if you build on the narrative that it's a flu, then you have misinformation, because actually it's not the same as a flu. And we know that there is a huge difference from an epidemiological perspective, and also on the effects that they have on the human body. So a binary classification is, I think, just wrong, and much more has to be done. Here we are doing just the analysis based on who shared those news, but we are missing completely the narratives and the development of a discussion. And there is no automated way that works pretty well so far, able to capture the type of information operations. So you need people to do that for the moment. And I know of a couple of proposals for European projects and so on that are just trying to attack this type of issue with massive artificial intelligence, for instance. But you still need people to do this job.
Thank you. Before we go on to the next question, there are quite a number of comments that just thanking you for the great talk. And someone is asking if this seminar will be available offline, and the answer is yes. We are recording the session, and just within, I don't know, if a few days or maybe weeks, it will be available offline. Probably in our YouTube channel or something like that. You will be informed about these details. Okay, so now the next question is from Emanuele. He says, thank you very much, Manlio, for the very interesting talk. I'm convinced that the understanding of the collective phenomena generated by the dissemination of information and disinformation online is one of the most important challenges of our societies. And as you have shown, the science of a complex system is very well equipped to deal with it. But the ability to study this phenomena is strictly related to the ability to obtain data that are owned by big social platforms. What is your experience with that? Do you think that this situation places artificial limits on the progress of the investigations?
Yes, actually, this is a very, very good point. So thank you, Emanuele. As you say, this type of challenges can be tackled only relying on the data, or actually big data. As I have mentioned, we are dealing with more than 500 million tweets, and we are aware that we missed many more than that. But actually, we are the group probably with collecting more data about this so far, just because we started before others. And the fact that the ability to understand these important dynamics of our society and also the effects of those dynamics and the fact that it depends so much on data that is owned by platforms and companies is not good. We have to get in touch more with those platforms in order to get access to the data. I have to say that during the WHO ad hoc consultation on this matter, there were representatives from Facebook and Twitter, and I think that they have some interest in helping more the research community in order to allow them to characterize what's going on in social media. For instance, just I have to mention this, Twitter a couple of weeks ago started to provide access to researchers to the fire hose, so to the whole amount of tweets about the COVID-19. Of course, you have to pass a selection process. You have to provide them with a proposal. But I think that the signal is a good signal from their side. And I have to say that I am still not able to work with it, even if my proposal was accepted. But at least it's a first step towards the right direction.
Okay, thank you very much. And okay, now we have one more question. Again, about the classification of fake news, rumor, and political news or information, and it concerns the biases. And the question is from Jose Antonio Garcia Orsa, and he asks how biased could be this kind of classification.
Of course, there is always some bias in the classification of whatever things when you work with data. We are using a database that we have been built from from expert classifiers, so journalists actually, and researchers working in this field. So according to their data and the way they classified the sources, the media sources, we can say that we are reasonably sure that the bias is small. That is of course over there, but it's very small. Okay. Of course, there are issues like a media source that up to 5 years ago was classified as a source of fake news, and nowadays instead more reliable. We are taking care of these changes in the classification of sources, and we are really up to date. So our classification lasts to a couple of months ago, so to January, February 2020. So we are reasonably sure that what you are doing now, it's a good proxy provides a good proxy for understanding the classification of fake and so on.
So it's sort of a work in progress in order to have a complete control of it.
Yeah, and actually it requires a strict collaboration with institutions and journalists. So we are in touch with big media sources, but also with data journalists who are willing to help us and to collaborate with us in order to keep this huge database really up to date. We are working on it, so this is really work in progress. We are writing with Ricardo a lot of agreements, and also Emanuele, for instance, knows this pretty well.
It's hard, but it deserves the challenge deserves the efforts. Yeah. Okay, so we have, I think, many more thanks and congratulations messages, and then I think that there is still one last question at least, and it says, can you say something about how to forecast how much the failure can escalate, for example, in the case of civil unrest?
There's the $1 billion question, because that's the big challenge. So far, we are in the phase where we are trying to understand how to make a diagnosis of the problem in order to be predictive and understanding now which are the early warning signals and of the failure and how it can escalate is more than work in progress. It's something that we should aim as a research community as a world, because it's really difficult to understand what will become viral and will have the chance to become to involve, so to become systemic, like for instance the action of Greta Thunberg or and so on. So this is pretty complicated. I think it's the challenge of the next decade. So as Emanuele was mentioning in his question, I think it's the real challenge of the next decade, because it requires a lot of theoretical work and a lot of data analysis and a lot of collaboration with people from specific domains like social science and psychology and so on. So a lot of work for the next decade, I think.
And so you think that it is in general possible? I mean, that there is some kind of, it's not completely indeterminate.
It's emergent. It's an emergent process. So I think that we can capture early warnings, like for other emergent processes. But now I go a bit to physics. If you have an abrupt transition between two different regimes, then it's abrupt. So there is no way to anticipate it. There is some way to understand it, but not way to anticipate or to understand at which point you are in order to anticipate. It's really tough, but that's why it's interesting, and I do think that I will be working on this for a lot of years in the next future.
Thank you. And we have an additional comment from Alvaro and another question from a different user. So Alvaro says that following media sources like New York Times have a high reputation. Is the reputation updated if New York Times disagreed with Financial Times and other media in a sort of page rank way?
So I don't know if I have the exact answer to this question, but what I can say is that there are thousands of people fact-checking everything worldwide. Now there are even institutions for fact-checking. I been in touch with some of them, and what's happening right now is that if there is a reliable source in disagreement with another reliable source, then they are working on this to inspect why they are in disagreement. So, and if there is a reason behind the disagreement, because the reason can be, of course, a lack of knowledge about the fact. And if for some reason there is a disagreement that is due to any reason, like for instance a political intervention, okay, so the fact that you have some political pressure behind it, they will update their classification for those media sources. When this will happen, actually, I think we get the update in a couple of weeks in our system. So we will update the status of that media source as well.
Okay. Thank you again. And then let's go to this, at least up to now, the last question from Jordi Baró. And he says, thanks for the nice talk, Manlio, and congrats for the good news. I believe that macromechanics observed in infodemics can be related to fundamental principles in order to disciplines such as in other disciplines such as behavioral psychology or game theory. Have you contacted or received any feedback from such research communities?
I perfectly agree with the introduction, and that's it's for this reason that we are not working on this alone as a physicist. We are collaborating for everything concerning the infodemics with another university, and specifically with a professor of cultural economics, expert on conspiracy theories and narratives and communication. With a strong basis, quantitative basis on game theory and social psychology, and specifically mass psychology. So we are working with them, exactly, because without their feedback and the feedback of those communities, we cannot achieve a real impact, a real result. It's the thing that I was mentioning in my slide. You cannot see a phenomenon from only one perspective, because the perspectives are made by us, by humans. But it's our limitation to attack the problem from psychology or from physics or from biology. Actually, the truth lies in the interconnections between all of those aspects.
Okay, thank you again. There is one other question, and okay, also Jaume Casademunt is also thanking you for the very interesting talk, while Daniel Gamari say thank you for the great talk, very informative. My question is, what are the ways to block spread of information, for example, fake news, which aren't destructive? For example, removing agents or connections.
Yeah, that's a good question about policies required to and for countermeasures against infodemic and the spread of misinformation, disinformation in general. We have been working with my lab also on this type of problems. We have attacked this with a complexity perspective, so working on networks. And I didn't mention because I had no time, but I think it's a very interesting work. We had Twitter data and then data from another social network, which is named Gab. It is less known to the general public, but the main point of Gab is that it's a copy of Twitter, but without moderation. So it's an unmoderated social network. What was going on over there is that in a while, specific type of content started to circulate. So we have been monitoring the discussion about Donald Trump, just to have an example, and we have been looking at the differences from the structure and the dynamics in both systems. And the results were very interesting because we see that essentially there are not a lot of differences from a structural perspective, and this is counterintuitive. We expected the gap to have other structural properties in terms of complex networks. But then, very, very interestingly, it was the response of those systems to our policies for isolating or the bad actors, so the ones sharing information with a negative content, if you want. Okay, so we performed some machine learning to have sentiment analysis and so on, and the results here are pretty different. So on Twitter, in practice it works to act on bad actors, but in Gap it doesn't work. You cannot just use the one, so act or isolate people sharing bad content or fake content. You have to account simultaneously for the topological information. So you have to include the relevance that they have for the spread of information inside the network. And when you join the two information, then you have a more reliable policy. But this is still open field, so there is no way to really solve the problem. I have seen that Twitter, for instance, is trying to block a lot of people based on flags by other users, and also they started to limit the use of retweets. So you cannot more. I don't know if it's already active here everywhere, but in US I think it is. You cannot retweet everything if you don't read it before. So, or at least you can retweet it, but it asks, "Are you sure you want to retweet it to your followers because you didn't read it?" So it's an interesting way to start to at least reduce the speed, to make some friction against the spread of misinformation.
This is very interesting because in the end it's something that we are, all of us are involved in this kind of policy making from the platform, and the relationship between the results that scientists you can provide to these companies and how they are able and willing to implement them or not. Okay, so thank you again. I think that since there is no other comment in this line, I'm pretty sure that all the participants are happy with your answer and find them clear. And there are again more congratulations and compliments. And there is just one last comments from Mariangels, and let me say that congratulations, and I also love the Twitter by Peter Dots about emergence. Yeah, it's very effective. Okay, I think that we can close the session now, and maybe I can give back the thank you everybody, and maybe Albert wants to say something just to close this first seminar, web seminar organized by the UBICS, or?
No, not really. I have nothing to say. Just say thank you a lot, Manlio. It was wonderful having you here. So we know that you are not so far, so that we are close. We meet, we talk from time to time with other people that your colleagues that you have a lot of not colleagues but friends in our let's say team of in the Catalan complex community. And you are always welcome, and it was really a pleasure to have you here. And we hope to see you around if you are able to do in the next seminars, and then we can close the loop, and then looking forward for.
I will be around for.
Okay, sure. Thanks a lot.
Thank
And so those of you that want to join us for a beer, sorry, that is not
you. Next year.
next
year.
Next time we are able to do it really, then we will go for a beer. I promise that. Okay, sure. Bye bye.
So
Bye.
bye.
Ciao.